Awesome. Thank you all. I got to say, this is one of my favorite conferences. Love to be here. Often spend a lot of time in the hallway track. So many great conversations, so many familiar faces and new faces. I love it. So if you also enjoy the hallway track, well, thank you for coming here to this one. So I'm going to be building off a little bit from the keynote this morning. Covered a lot about bootc. Obviously, you heard about last year. In this talk, what I want to do is we'll use a specific user scenario to start, but I want to really take this a deeper dive into this world of system provisioning, because how do I get started is such a key aspect to this. And, obviously, people still ask this question. Well, wait, how is the container bootable? How does all this work? How do I do this or that? And a lot of details here. And I really want to take a deeper dive into different aspects of this and how it applies to our user scenario. So we'll also be talking about Linux happens inside the container image and outside it. So there's a lot of, you want to lifecycle bind, you want to put as much content as possible to define your OS inside that base container. But some other aspects may live outside or be external to it, such as secrets or partitioning. And then I do want to dive into what's next, like where are we going with some of this technology. And cool, so yeah, our user scenario here is, right, I just want to deploy these images on bare metal, but to succeed at that, I need to test in the cloud. Like, obviously, you can have your bare metal testing machines in your staging lab, but for a lot, it's just obviously a lot cheaper to scale out your testing across the cloud. And there's obviously a bunch of tools and techniques that you can use in this scenario, but there's challenges. One that feel like a showstopper in a lot of this is just dealing with that zoo of different formats. As soon as you start talking about virtualization, well, there's no real standard for virtualization formats. There's a lot, right? And as soon as again, the user scenario here is they're deploying a bunch of edge devices, but they have a CI team that needs to go and, okay, well, here's how we're going to do this, in GCP, for example, or whatever their chosen public cloud is. GCP, for example, has this really cool concept of image families and things like that, how you define the images. But you got to go learn that too, in addition to knowing your sort of core competency of how you deploy to the OS. Obviously, KubeVirt, which is one of my favorite, has a container disk, which I love because they basically just sidestep the whole thing, put a disk image inside a container. And as soon as, again, your CI jobs, you want to go into this world, you have to think about, okay, well, how are we going to version all these disk images? How are we going to inspect them, garbage collect them, all that stuff? Also, as soon as you step in the cloud world, you may think, well, okay, how am I logging in? You have to think about agents. It's a whole challenge. The agents are often tied into system provisioning. In Azure, the agent, by default, the hypervisor will kill the OS unless an agent checks in, right? And so there's all these details you got to think about as you want to, again, their goal is to deploy on Metal, but you want to get as close as possible to testing what you're running on Metal in these instances. That's just something you got to think about. Challenge. Build tooling really varies. I still think it's kind of wild if you look at some parts of the AWS stacks, there's a lot of tools, but they kind of encourage this model of just start a machine, mutate it, and then snapshot it. And that has all sorts of problems around, well, your SSH keys get stuck in this thing. There's build tooling, again, can vary a lot. And languages, all this stuff, all this history did not go away, right? How we configured Linux before continues to be an anchor, right? And then again, there's this zoo of stuff. Kickstart, blueprints, Kiwi XML. I think a lot of you know this stuff. A lot of that stuff didn't go away, and some of it's very relevant, right? Because it configures parts of Linux we still need to continue to use. Okay, so there's this powerful pull, right? Let me make as much common as I can between the bare metal and the cloud. Cool. So you saw last year, you saw this year again. Where we see bootc and where I feel it's really been successful again, we obviously can run just fine in plain virtualization. You don't care about bare metal, you're only in the cloud. Great, I mean, we'll target that. But I think this domain where you want to cross infrastructure, that's where the rise of OCI has been great because it creates this powerful common tooling. So we crossed off some of these things on the list, or at least made a big dent in them. Agents can still be there and still be relevant. We'll touch on that. And the language thing also didn't go away. Like that's something you may need to understand because we have different languages around, especially around partitioning and things like that. So let's dive in to the sometimes here, the components. And before we do that, here's a sort of key principle that we're trying to preserve. How we upgrade the thing, like making something is 20% of the work. It's actually maintaining it over time is 80% of the work, especially if you think about, well, you know, my team members rotated, right? Maybe they used one thing before, you know, the earlier team was all about Terraform, and now we're doing something else, right? It's that maintenance that's huge, and it's so important to have, in order to have a system be maintainable, how we install it should be as close as possible to how I maintain it over time. So yeah, that's that kind of core principle. And in my opinion, you know, the sort of stock cloud images you get kind of violate this principle because, you know, I go and I boot a container disk in KubeVirt, or I go boot an AMI in AWS or whatever. If I'm doing an apt update or a DNF update, there's two fundamentally different things that happen there, right, that operate on different levels. You know, I like to say apt has no idea that its initial state came from this image family. Now, of course, you know, it may have been involved some in the creation of that thing, but you still kind of have these fundamental different things going on. And of course, some people say, okay, well, yeah, they got bit by this. And so they basically say, okay, well, we're not going to do any in-place updates in the cloud. We're just going to put everything in an external volume, and now we can't have state leakage, right? I always know when I launch the thing, the cloud image is a source of truth. It's great. I mean, it actually works pretty well. If you can do it, yeah, do it. But the core problem is, again, going back to our user scenario here, on bare metal, I don't have this cushy layer of giant amounts of cloud infrastructure underneath me, right? Like, my bare metal edge device can't just go, yeah, again, there's none of that stuff, right? And so, well, again, for this user scenario, what we're really trying to achieve is to make sure for our bare metal machines, how they upgrade and are maintained over time is just as close as possible and doesn't drift. And yeah, obviously the same thing is true if you're starting from an OCI container and just kind of upgrading it in place. So this example, I blurred the source of it. I found this when I was digging into a cloud image you can find an important cloud provider. And I'm not trying to roast. I have, you know, obviously everyone is building something. You got your load-bearing shell scripts, little bits of stuff run as root. But the thing is, like, there is just this invisible, yeah, when they're building the image, right, like 80%, 90% is packages, but there's this extra mystery meat, dark matter, I don't know how you call it, like the post-processing scripts that grow over time, right? That, you know, and this one was clearly well-intentioned. I didn't go and get log why they did this, right? Maybe there was like most of our networks don't run IPv6 so in the cloud, so we're just going to turn that off. But you know, if your goal, right, your goal here is to build this OS and test it for these edge devices, and maybe you're all in on IPv6, and you're trying to like start from this stock cloud image and maybe mutate it, you know, maybe you override it with the kernel that you're using or add your services. If you try and go that way, you're going to like run into this stuff, right? There's this invisible extra stuff in a lot of these cloud images. And this is not a roast again. Like there's a lot of these things. I just thought this was a really good example of one. And something I love, of course, about bootc, right, is it's so easy to see this extra stuff, right? Because it's just an OCI container. It's so easy to inspect it out of band and scan it and understand what's going on. But that's not the, oh, it was just lagging. So our goal here, we're going to, my slides got out, or sorry. So here's, let me set the cloud aside for a sec. So here's our goal, right, is one, in data center metal, something that works really well with bootc is to build a generic image and then specialize it through Kickstart. Because I've talked to a lot of, in the Fedora derivative ecosystem, Kickstart and Anaconda just has this huge presence, right? It's how we've been provisioning bare metal for a long time. And so this is an example of something I think works really well, where I want to deploy a generic image, but I want to use static IP addresses on bare metal. And this is where the two worlds of how we provision Linux before kind of seamlessly could transition into this bootc world. Like we linked into this existing ecosystem. We didn't create a new installer in this sense, right? We just plug it in, that existing Kickstart verb, a thing to configure Linux that existed before, we continue to use it. And so this is where we don't need to recreate something, right? We're able to leverage what existed before. Sorry, something definitely went wrong with my slides. Yeah, and so the backing of that was obviously our whole flow is right. We build a container and just push it to a registry, right? We use those existing familiar tools. We can test it in Vert, as I'm talking about, like use the things you saw before and last year to make disk images or provision it and test. But then when I want to go to Metal, I can plug into that ecosystem in data center Metal. So it's really, this is a really cool and powerful technique, I think, to create a generic image. Right? So backing up, we're not trying to go and take that cloud image we found for AWS or GCP or whatever cloud and kind of mutate it to look like what we want on bare metal. We're gonna start from a generic image, and we know exactly what's in that. There's no mystery meat, there's no dark matter, it's exactly what's in there. And then the cool part is, you can use OCI layering, this concept of derivation that exists in OCI, where it's a series of layers, and you can create a chain of images, right, that share a common language, applies so well to this problem domain. So again, in Azure, where you need a check-in agent, you can just say from your bare metal instance, install an Azure agent that does that initial check-in. Or in a lot of clouds, cloud-init is a key mechanism that lets you inject, for example, SSH keys. It's also a good way to handle secrets. And so again, if you're doing testing, like it feels good. Like I guess let me put it that way. Like when we created this, it kind of just worked for a lot of these. And of course, we're doing this. When we're shipping rel image mode, for example, in some of our CI pipelines, we are creating these derived images with the test infrastructure. Yeah, and it just works. So the agent problem, again, didn't go away. There's a lot of these things. But in some cases, you don't want an agent at all. And I'll talk about this a little bit later. But a cool part is, as you go down this route, you can say, oh, I don't need cloud-init. I can have my source of truth be the bootc image, right? I don't need to dynamically inject and mutate the system when it starts. And I've seen the light bulb even go off for some people. It's like, I could even turn off SSH, right? Why not go all the way in towards this world? But agents, again, we support it both ways. It's up to you. And yeah, so for this scenario, which has always been important to me, all this tooling that we've created works and is stable. Like, again, what you saw this morning and last year, we're targeting this case. Just got to emphasize, I think it's worked out pretty well. And it's really cool, right? Like what we've been able to achieve. So moving on, though. Again, the goal of this talk is to talk about provisioning. And it's a wide, complicated world. One that I think we'll need to handle better is a use case where I want to create a disk image that I can DD to drives of edge devices, but then have them start and kind of self-encrypt and install. This is something we just need to streamline a little bit better. It's totally possible to do with crypt setup, re-encrypt. But that's a kind of yet another different case. That's obviously totally different from the Pixie boot data center case, et cetera. Another kind of hybrid case is where I really care about the first boot provisioning time. Maybe this bootc instance is actually a Kubernetes node, and I'm using cluster autoscaler, and I really want, whenever I get a new pod, to spawn up a new VM as fast as possible and have it start running. And so it needs to, I can't be reinstalling it on first boot. I really want it to be booted directly in the target state with an up-to-date kernel and everything. So that's one half where I'm pre-creating this cloud image, but half of my partitioning may be somewhere else. It may be, actually, I want to leverage the instance stores. There's sort of general best practice in the cloud. And in that case, you can't do that at build time. You have to do that runtime. So we can't hide this essential complexity of some partitioning is at build time, some partitioning is at runtime. It just, is the thing that existed before, will continue to exist. And yeah, we just clearly need to support. And then there's another complicated case where if we want to support in-place upgrades from an existing system without destroying them, or I want to dual boot, something like Universal Blue or like a desktop OS with my Windows, and repartition. It's hard to get away from having a GUI installer that can do dynamic things, and we definitely don't want to recreate a new one of those. So there's this wide world of system provisioning that we need to plug into that, again, already existed, but we want to work well. So let's back up, though. So obviously, a lot of this stuff that we've shown, like the kickstart. Sorry, I've lost my timer, so I need to. Where I am. OK. So the kickstart integration that we've shown, to install in bare metal, or the ability to make disk images directly. There's some design stuff that went into this that we hadn't covered, and I wanted to kind of back up for a second and go back to that core principle, why does it work this way? And going back to how we upgrade should match how we install should match how we upgrade. And OCI images are naturally files; they're not file systems, right? So when I make a container image, it's agnostic to whether XFS or Btrfs or Lux or RAID or all that stuff, or a stack of all of those things is in use. Right? We have a generic, it's naturally file-based. This gives us a lot of flexibility. As I like to say, OCI images are just tar with JSON, which we've extended, obviously, in order to support bootc installations. So this is a really powerful property because it gives us a ton of flexibility. One is that not only can we support creating a generic image that can be installed to multiple different file systems, you also don't need to worry about the kind of classic dual partition sizing problems. As soon as you're making disk images that you try and install to partitions, all of a sudden that implementation detail of, partitions kind of have this fixed size, that's something you will hit, right? When you're going to deploy on Metal or in cloud that does in-place upgrades, we just have this inherent natural flexibility. And because we have that file-based architecture, that's also how we install, right? The center of gravity, the sort of core, is all based around files and not file systems that were pre-created. Now, we do need to, in some cases, obviously support starting from a disk image, as we do today. And this idea is manifested in the bootc install to file system, where the container image that you build can be self-installing. bootc knows how to take the contents of its own container image and then materialize it to a file system tree. This is a sort of core abstraction. And let me back up on this because, remember, we do support transactional in-place updates in a sort of A/B style feel, which means some people get hung up on this and they think, oh, well, what goes on the disk is just what I see when I podman run it, which is true, but it's not true. It's not true in the sense that, OK, yeah, I'm going to have to fly through the rest of this. I thought I didn't have enough content, but I have too much. We're going to have to set up an EFI system partition. The bootloader, all that stuff comes from the container image. And so this is a sort of core abstraction. The compose.fs work that's been happening, that all is using is using this abstraction, where we install on top of an existing file system. And yeah, this idea of what initializes the partitioning is up to you. OK, so, but we did get here, and we have 3 installers in our Fedora derivative ecosystem. And again, that's because there's some history to it. There's also some tools designed for specific targets. Again, for us, Anaconda has been a very flexible way to install on bare metal. And in cloud, we invested a lot in image-builder as a way to create cloud disk images. It also comes together where the image-builder tooling can make ISOs as well that install with Anaconda. That's where you need to understand these 2 worlds. So there is this how we got here aspect to it. And then there's actually a 3rd installer. I was hoping to have time to demo system reinstall bootc. This is where you want to just try things out. You don't want to go make a disk image to even test or just play with bootc. You can just reinstall an existing instance. So we have 3 installers because they just kind of have fundamentally different trade-offs, technology wrapped around them. There is bootc installed to disk, but that's just a toy. And it's so flexible, though, for us to be able to not be tied to pre-computed disk images, because we need to sometimes create dynamic state, whether that's encryption, whether that's at runtime deciding, or initial first boot deciding what our partition should look like, because that's what a GUI installer said, or that's what some other systems management said to use. And where we're going with this, because of this flexibility, we can have a unified object store. Basically, to have deduplicate between multiple images that are stored into a single file system tree. That's basically how bootc works, and that's where we'll be evolving things with ComposeFS. Something that also didn't go away, and I'd love to make progress on in our ecosystem again, we have a lot of languages. This is what I mentioned at the start, which is also a challenge. And these languages, in theory, should be usable inside the container build as well as outside. So, I've talked to some people who are actually just porting from Kickstart. It's kind of this idea that, this image mode, bootc thing is cool. I'm going to take my Kickstart, I'm going to translate it to a container file that says run DNF install for whatever was in the packages section. Or I'm going to move the time zone over manually. But you have to translate languages when you do that. It's not hard. But some of these things can be pretty non-trivial. There's nothing technically that stops us from doing that inside the container. And this is something I'd love to do in the future and make progress on. We actually have a spike or 2 on this. But it's a lot because some of these tools, again, like Anaconda, were always designed around live mutating the target thing. They assume they're running in a virtual machine. They're not designed to run in a container image yet. And there will be some porting involved for that, but that's something I'd love to make further progress on. And obviously, because the different tools evolved in different environments, the language is unfortunately coupled to the tool, which I'd like to sever a little bit. And you really see this in bootc-image-builder today, which, in some cases, you have to think in terms of Kickstart. If what you want to do is configure the bare metal machine that you installed and configure its file system, as opposed to the cloud image with blueprints. And so, sorry, I don't know what's going on here. OK, this thing just stopped working. I'm going to skip the CoreOS ignition. So, yeah, there's definitely a lot of cool stuff happening. Did you say I had 10 minutes left? Sorry, 5 now? 6. All right. So, OK, yeah. So now what I think is cool is we're trying to invert the flow, right? Where I want to build a bootc image that is a source of truth even for its partitioning. So I can now, thanks to Alex, who's working on some automotive-related stuff, embed my desired partitioning in the image. So I don't need to carry around, there's this external config that defines that stuff. So that's going to be cool. But just to flesh out what I'd love, I know there's one or two Anaconda folks here. What I'd love to have, because again, Anaconda has so much knowledge, I'd love to, the inst.bootc idea is for people who are pixie booting. Well, I can actually just put my Kickstart there, and then I don't need to, Kickstarts are just designed to be kind of hosted on a random web server. I mean, it's fine, it works, it's low tech, but it makes you invent, how do I version these things? How do I do all that stuff? if what your source of truth was a registry, all of a sudden we've collapsed that set of things I need to version, understand, or manage. A big thing I would love to do and been talking with some people about is where we support doing this even in cloud. So I want to do something complex, like I want to do a bootc image in a cloud with Lux on LVM and be able to like interactive, be able to leverage Kickstart, like have most of the stuff again in my container. This is where I'd love stuff to go, and this would kind of replace what is now system reinstall bootc with something really powerful and flexible. My laptop's lagging, sorry. Okay, so there's a lot that's happening in the bootc-image-builder world too. One thing that's kind of cool, it's in progress, is basically automatically KVMing itself so that when you, because the sort of core problem we have is when you're running as an unprivileged user, you can't create full complex file systems there, so there's some in-progress work to like automatically virtualize itself so you can do that, and like you can live on Linux in an unprivileged Podman, so that's going to be cool. But there's definitely some work we have to do, I think, to streamline its integration with Anaconda and make those feel good. I'd love, for example, also to feel like I can just run this in Kubernetes, or I guess it's a cron job too, and like have it operate as a controller where I'm polling for the registry for new container image versions, and I'm mapping that to a cloud image like an AMI or whatever, and I'm reconciling if they get async. It's not hard to do. External to the tool is just not built in, right? And that's the kind of thing we could also do as well. Yes, let's see. I have no idea what's happening with mine. Yeah, I covered this one a bit, but yeah, this is where there's a lot of tricky details for the configuring inside the container case, especially around things like users and SSH keys. But again, for that user who's porting from a package-based Kickstart world to this, we could definitely streamline this a lot more such that they can actually run some of the Anaconda logic, some of those verbs inside the container. And again, how some of those things work, like SSH keys where you actually want it bound to the image and not to any local mutable store. You can get to some interesting details, but would not be that hard. So for example, bootc has its own declarative kernel argument thing that reconciles across boot, because Anaconda is always a one-shot thing. You configure it, you start it, you define your kernel arguments, but it doesn't help you reprovision day two. Whereas a beautiful thing of what we do, right, is you want to change your kernel arguments, you can do that through that drop-in and get a transactional in-place update. Like that's a whole giant thing. All this. Yep, and I definitely want to have some time for questions. I have no idea why my laptop is lagging. We are looking at kind of streamlining the local vert experience, so that's something that's in progress I'm really excited about. Again, that's the use case of, I did a Podman build of my image, great. Now I want to like launch in libvirt, how do we make that streamline? That's something we're working to polish over and streamline. But I think I won't have time for this demo. Sorry, I ran out of time. But yeah, I want to have time for questions, so let's go ahead and do that. Thank you, guys.
So if you have questions, please raise your hand and I'll hand you the mic.
Well,
thanks. Hi, thanks for the session. I do have a question. I'm looking to deploying things via bootc, but in an environment that doesn't have any DHCP and stuff like that. So basically on Metal with like mounting onto the iDRAC interface of a Dell server or something like that. And I'm trying to build like a minimal ISO that would have bootc on it and actually pull the image from the registry while the server is booting and then installing it to disk.
Yeah, so the great thing is that basically already works because what we have, right, the Anaconda ISO we make can be come in a minimal form. So yeah, a kind of common problem on bare metal is you want to, the size of the ISO you can attach with virtual media, you can run in limits with that. But yeah, we already support network installs, basically, because we already have the Anaconda installer. Your kickstart that you inject into the boot ISO that you attach via virtual media can just reference something else in a registry, right? So there is some bootstrapping. This is in the docs, right? So common problems are, okay, well, I need a pull secret to do that. I may need to, configure the certificates for the internal registry, and all that stuff's basically supported by adding it to %pre in your Kickstart. So you just have some bootstrap stuff, and yeah, that all just works, basically. Yeah. There's one over here.
Yeah. So I would like to ask about, in our case, for example, we support internally like a provisioning offering, right? So people can provision a compliance instance. We are looking at bootc, and one of the questions I have is like, okay, you can boot a VM that it's immutable, but what about, for example, registration to a IDM, for example, or satellite, right? Like, is there some way to make this happen maybe in the first boot, so the VM boots and then it becomes registered into the satellite, but it's immutable?
Yeah, so I tend not to like the term immutable because I think there's actually a spectrum. And so we actually support etc and var default to per machine persistent volumes. So if you do want to do a kind of dynamic registration or compute some data on the client, like again, maybe the client creates a certificate, like however the registration process for your agent works, that can write something to etc, and it's not immutable in that sense. That will persist across upgrades. And that's the same way the static IP addresses can work with Anaconda and bare metal, right? Like we do persist this data. It's just the user, basically the stuff that came from the container is the bit that's immutable because in that case, the registry is the source of truth, right? Like I don't want that stuff to drift, but I can have other data that's instance local. And so yeah, we continue to work on those kind of patterns.
Thank you. We'll get that tested.
Cool. Awesome.
Hello. Yeah, you had on slides inst.ks using OCI artifact to basically get the kickstart file, and I want to just verify this is meant to be really a kickstart file and the artifact for just like downloading the kickstart file. I like the idea in general, and also the checksum, I guess that's optional. Am I correct?
Yeah, you can definitely fetch things from a registry without specifying the SHA digest ahead of time. I don't have a strong intuition for if we did the kickstart as OCI artifact or something like that, would it feel compelling for someone who's already deployed at scale? I can't say that for sure. What my intuition says is that for someone who's coming new into this world and is starting from bootc, it feels natural to put stuff in a registry. And to have this world where, oh, there's this other thing that pre-exists OCI and I just need to stand up a web server somewhere, it just feels weird, right? So yeah, I mean, obviously there's nothing deeply wrong with what we have now, but yeah, I think it'd be worth doing. He had one other.
Don't return it.
Yeah, definitely I agree. I want to also know that for Kickstart file, to get it downloaded, you basically need to set up HTTP server. It's not that hard, but still you need to have a server. This way, you can use any public registry with a login or anything like that. That's much easier to access and much easier to use. Just podman push, or I'm not sure if podman push supports something like a Kickstart, but I guess there's a similar tool.
Yeah, that's absolutely right. So I can add some color to that. So actually in Podman, the recent Podman, there's an experimental artifact command, which, again, the way I would explain OCI artifacts in a nutshell is OCI images, like Docker containers, are just tarballs inside. What if we used the same JSON schema, but put things that aren't tarballs in it? So again, and it doesn't need to be architecture specific. So, there's discussion of putting AI models as OCI artifacts, because the problem is it gives you also a way to have a sort of no arch for OCI, among other things. But yeah, Kickstart is kind of naturally architecture independent. And yeah, it's basically, you could push it to Quay or Docker Hub or whatever and version it that way. Yeah, but it's Podman artifact as a way to make those and push those. Yeah.
And with this, we are out of time. Thank you very much for the lively discussion. Thank you, Colin, for your talk.